Hi everyone, today I'm investigating the internal resistance of a biological battery, specifically a lemon battery and how it behaves under different loads. For this setup, I'm using a fresh lemon as an electrolyte, a copper strip as the cathode, and a zinc nail as the anode. I rolled the lemon beforehand to release the juices and ensure better ion flow. First, I'm checking the open circuit voltage or EMF with no resistor connected. As you can see, our lemon battery is starting out at a solid 0.904 volt. I have connected a 560 ohm resistor, and as you can see, the terminal voltage drops sharply to 0.075 volts because of the high internal resistance. Switching to a 10,000 ohm load, the voltage recovers to 0.586 volts as the current draw decreases. At 100,000 ohms, the battery is much more stable, giving us a reading of 0.817 volts. Using a 220,000 ohm resistor, the terminal voltage climbs back up to 0.872 volts. Finally, with a 230,000 ohm load, we finish at 0.880 volts, which is very close to our original EMF. Now, let's look at the main data table where I recorded all the measurements. In this table, you can see how the terminal voltage changed across 5 different load resistors. When I used 560 ohm resistor, the voltage dropped significantly, but as I increased the resistance of 10,000, 100,000 and up to 330,000 ohms, the voltage steadily returned toward our initial EMF of 0.904 volts. In the final column, I have listed the calculated current for each trial in milliamperes, which I found using Ohm's law. These data points are essential because they allow us to calculate the internal resistance through the linear regression. With the formula V equals EMF minus I times R, I calculated the internal resistance of experiment results. Here you can see the average internal resistance of the lemon battery as 7.85 kilo ohms. In conclusion, this experiment successfully measured the internal resistance of a lemon battery using various external loads. Our results show that while the battery has an electromotive force of 0.904 volts, its performance is limited by a high internal resistance of approximately 7.85 kilo ohms. This confirms my hypothesis that the battery acts as a non-ideal voltage source where the terminal voltage drops as more current is drawn. The project demonstrates the fundamental relationship between voltage, current, and internal resistance in a real-world biological cell. Thank you for watching my video.